turbine, any of various devices that convert the energy in a stream of fluid into mechanical energy. The conversion is generally accomplished by passing the fluid through a system of stationary passages or vanes that alternate with passages consisting of fin-like blades attached to a rotor. By arranging the flow so that a tangential force, or torque, is exerted on the rotor blades, the rotor turns, and work is extracted. Turbines can be classified into 4 general types according to the fluids used: water, steam, gas, and wind. Although the same principles apply to all turbines, their specific designs differ sufficiently to merit separate descriptions. A water turbine uses the potential energy resulting from the difference in elevation between an upstream water reservoir and the turbine exit water level, the tail race, to convert a so-called head into work. Water turbines are the modern successors of simple water wheels, which date back about 2,000 years. Today the primary use of water turbines is for electric power generation. The greatest amount of electrical energy comes, however, from steam turbines coupled to electric generators. The turbines are driven by steam produced in either a fossil fuel-fired or a nuclear-powered generator. The energy that can be extracted from the steam is conveniently expressed in terms of the enthalpy change across the turbine. Enthalpy reflects both thermal and mechanical energy forms in a flow process and is given by the sum of the internal thermal energy and the product of pressure times volume. The available enthalpy change through a steam turbine increases with the temperature and pressure of the steam generator and with reduced turbine exit pressure. For gas turbines, the energy extracted from the fluid also can be expressed in terms of the enthalpy change, which for a gas is nearly proportional to the temperature drop across the turbine. In gas turbines the working fluid is air mixed with the gaseous products of combustion. Most gas turbine engines include at least a compressor, a combustion chamber, and a turbine. These are usually mounted as an integral unit and operate as a complete prime mover on a so-called open cycle where air is drawn in from the atmosphere and the products of combustion are finally discharged again to the atmosphere. Since successful operation depends on the integration of all components, it is important to consider the whole device, which is actually an internal combustion engine, rather than the turbine alone. For this reason, gas turbines are treated in the article internal combustion engine. Water turbines are generally divided into 2 categories: 1. Impulse turbines used for high heads of water and low flow rates, and 2. Reaction turbines normally employed for heads below about 450 meters and moderate or high flow rates. Impulse turbines. In an impulse turbine the potential energy, or the head of water, is first converted into kinetic energy by discharging water through a carefully shaped nozzle. The jet, discharged into air, is directed onto curved buckets fixed on the periphery of the runner to extract the water energy and convert it to useful work. Reaction turbines. In a reaction turbine, forces driving the rotor are achieved by the reaction of an accelerating water flow in the runner while the pressure drops. The reaction principle can be observed in a rotary lawn sprinkler where the emerging jet drives the rotor in the opposite direction. Due to the great variety of possible runner designs, reaction turbines can be used over a much larger range of heads and flow rates than impulse turbines. Reaction turbines typically have a spiral inlet casing that includes control gates to regulate the water flow. In the inlet a fraction of the potential energy of the water may be converted to kinetic energy as the flow accelerates. The water energy is subsequently extracted in the rotor.